Exactly. So we're moving in that direction.
But you move the decimal right.
Which way did I go from here?
Left.
I moved it that way. So which way am I going to move the decimal?
Oh,
that
okay.
way. Yeah, cool. Because it starts, of course, at the end of the number.
Yeah.
Cool. So what if I had 0.0028 deciliters? How many milliliters would that be?
How many milliliters?
28. 280 total. Sorry.
So you only have to move it how many times? You have to move it 1, 2, 3, 4.
Right. So it'd be 280.
1, 2, 3, 4. Right? From here to there, it's 4 steps.
Oh, I'm counting deciliters.
Yeah, this is where I start. Do I count that as a step?
No.
No, I haven't stepped yet. 1 step, 2 steps, 3 steps, 4 steps. Right? So then 1, 2, 3, 4.
So if you're at hecta, then.
Then it would have been 5, sure.
Oh, okay. I'm
Right.
thinking you were at hecta.
Do you guys see that? I mean, that's crazy. That is silly, stupid, easy. I'm hoping. I mean, there's nothing more than that. If I have 0.01012 kilograms, how many centigrams is that? So you guys give me dizzy watching you all doing.
12.
Yeah, you have to move it how many times? You gotta be careful, there's a 1 there.
1,012.
So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 1,012. Cool. That's silly. That's awesome. All right, so converting within the metric system is easy as hell. Okay, so that's number 1. In section 8.4, we'll be converting from metric to hours and the other way, which is disgusting as hell. Because our system by itself is disgusting as hell.
It's not even.
Not our fault. That's just the way it was.
That was good timing.
Yeah.
Now, there's something I had said before, earlier this semester, about area and volume and all that kind of stuff.
Yeah.
So if I have something that's the area is, if I spit it out, I don't know, 10 meters squares, 10 square meters, and I want to know what is that in square decimeters.
It's 100.
Now you can't just say I take 1 step and there I am. Why can't you say that? Because I know how meters and decimeters work, but how do square meters and square decimeters work? They're actually exactly related to each other. Let's see how it works. Let's do this here. An area of 10 square meters.
100.
What's one way I could do that on some, wouldn't this be like, if this was 2 meters, what would this be? 5 meters. Is that cool? You could do 1 and 10, whatever. The idea would be the same. 2 meters is how many decimeters? How many decimeters
20.
would 2 meters be?
20.
20, right?
Wait.
If I'm here, 2 meters would be how many decimeters? Move 1 over.
1.
Okay.
Move 1 over, so 20. How you guys doing? Right? And 5 meters would be how many decimeters?
50.
50. Move 1 over. So what's the area of this in square decimeters then?
100.
Careful. 20 times 50.
Oh, 1,000.
Yeah.
So would it be the number, the exponent would be the number of times we move over the decimal?
No, careful.
No? Okay.
You actually, there's a couple different ways to look at this. The easiest way, personally, the easiest way is if you're gonna move, if you have to move 1 step over, you have to move twice that much, right? If I have to multiply this by 10, if 10 meters would be how many decimeters?
100.
100. So don't you have to multiply by 10? Squared, I got to multiply by 10 squared. What's 10 times 100? 1,000. Now, where have we done that before? When I had like 4 yards, how many feet is that?
Oh,
12. 12 feet.
12 feet, right? You'll multiply by 3. But 4 square yards is how many square feet I gotta multiply by 9. Because now I have a square, right? So each side would get multiplied by 3. So overall I get multiplied by 9. Incredible. So I have to multiply this by 9. So I get 36 square feet. What about 4 cubic yards? What do you think I have to multiply now? 27. 3 cubed. Do you guys see? No, whatever the situation, if it's a straight up first power, you multiply straight up by the number. In this case, 3, because yards to feet is by 3. If it's squared, if it's area, then you square the number you multiply. So now I multiply by 9, 3 squared. If it's cubed, volume, I don't multiply by 3, I multiply by 3 cubed, 27. Right? What is that, 108? Maybe. We've done that before. We've done exactly this kind of thing before. Now I'm just doing it with metric units instead. To me, I like the idea that if I take 1 step for meter to decimeter, I take twice that for square meter to square decimeter. Because every step is 10. So twice that would be 100, right? That's exactly what I need.
So if it was cubed, it would be 10,000.
Yeah, if it was cubed, I'd take 3 steps over. Cool.
Okay, what is that symbol beside the 100? I'm
Oh,
trying to read your handwriting.
Decimeter. Yeah. So let's do a couple more examples. Yeah.
Okay, the 4 yard equals 12 feet, right? And it's 9 because in a yard there's 3 feet, right? 3 times 3
3
is 9.
squared.
Yeah, okay. 3 to the
3
third.
cubed.
Okay.
To me,
Because
it's very
yards,
simple. If it's square units, I square the number I would normally multiply by. If it's cubic units, I cube the number I would normally multiply by.
Okay.
Cool. All right. So how about, let's see. So let me show you, I think the most direct way to do this, the way I do it, if I have 16 square hectoliters, how many square deciliters would that be? I would normally take how many steps if it was just not squared? I would take
3.
1, 2, 3. Since it's squared, I have to take twice that.
Just 6.
6 steps, right? I would normally multiply by 1,000. Now I've got to multiply by 1,000. So if I take 3 steps, normally 1, 2, 3. Since it's squared, I just take double that. If it was cubed, I'd just take triple that.
So that way, okay, so then you would move the decimal place 6 points on that one?
Yes, good. 6 points that way. So it'd be 1, 6, 1, 2, 3, 4, 5, 6.
16.
Dude. Or you could, if you want to. You certainly could make this very visual. What's the easiest way to have something that's 16 square hectoliters? Have each side
4 by
be
4.
4. Now watch this. This is kind of nice because it works itself out. 4 hectoliters is how many deciliters?
4,000.
Yeah, you have to move it 1, 2, 3. So 4,000.
Would you get
So
4,000?
4,000.
From
Again, if I got 4 hectoliters, how many steps do I take to get to deciliters? 1, 2, 3.
So would it be 4,000?
So I move the
deciliters
decimal over.
squared?
1, 2, 3. How we doing? I mean, the basic idea of moving the decimal the same number of places that you have to move to just to get around the King Henry thing, that still works.
You wouldn't put squared on that one?
I'm not done. I'm not done yet. I haven't done the area yet. You can never have a length equal a length squared. So this side, how long is this side? 4,000 deciliters. I mean, how long am I doing square hectoliters? Oh, I mean meters here, but let's just stick with this. If I somehow have square liters, what would 4,000 times 4,000 be?
16 million.
16 and then 1,000, right? There's 1,000, 16, yeah, 6 million. So you could do it visually if you want to. Nothing wrong with that at all. And actually, if you really want to, you can always make it 1 by 16. You can always make it 1 by whatever the hell the number is. If I do cubic, you have to know how to draw a little cube, right? So if I had, for example, let's say 4 cubic meters is how many, let's go the other way, cubic decameters. So if I draw a little cube, however you want to, or if you want to, if you're not really good at drawing 3D, you just put two squares next to each other and you connect the corners. Bam, you just drew 3D. Now the easiest way to make 4 cubic meters is to make like 114. Is that cool? That's the easiest way to make 4 cubic meters, to make 1 meter by 1 meter by 4 meters. This one by itself is how many decameters? So if I'm in meters now, how do I get back to decameters?
Move the decimal to the left.
Move it back 1.
So
So that'll be
0.04.
0.4. Careful. I only have to move it once, right? From meter to decameter, just have to move it once, just one step. Here would be 0.1 thing. And here would be 0.1. What's 0.4 times 0.1 times 0.1? What happens every time you multiply by 0.1? The decimal has to move back once, right? So 0.4 times 0.1 is 0.04 times 0.1 is 0.004. What's the other way to look at this? The way that I personally like better. How many times do I have to move it back normally? Once. Since it's cubed, I got to move it 3 times that. 1, 2, 3. 1, 2, 3, bam. Both ways, of course, lead you to the same number. The reason there's a lot of different ways to do this is because they based it on 10. And 10 is all about moving the decimal around. There should be a few different ways to do it. Now, the nice thing about this homework, because I know some of you guys are a little worried about that, most of it's going to be about just take this shape and show me what the area is. And they actually give you the formula you need for the problems. For example, look at, I jump around a lot. The reason I do that is because some of these problems are, oh good, they took that out, okay. They used to have like a word scramble, and to unscramble the word to make the metric name. I'm like, word scramble? Really? So I kind of skipped over a lot of that crap.
Okay.
Look, for example, on page 488. Let's see. Let's do number 106, because that's an interesting problem right there. I'd say 488. 106. Read through 106 real quick. If your book survives spring break.
That's still in break.
Huh?
My book is still in break. That's
Now, anybody know what I would call that kind of problem? Cookie cutter problem, right? Because you really have, here's the whole thing. Here's the actual picture. There's a lot of freaking mat on that thing. Here's the mat. The mat is that covering on the outside, right? So they tell you the whole area is 20, what do they say? 2540 square centimeters. And then they tell you that the picture's dimensions are who by what?